This video is a demonstration of a Raspberry Pi being set up as an Internet Intercom Receiver for voice audio and also, for this experiment, Morse code audio. So on the picture view here, the webcam, we have the Raspberry Pi in view on the left. It's using a Wi-Fi adapter just to see how it does with Wi-Fi in addition to the normal Ethernet direct connection. And we're separating a stereo signal from a VoIP Opus program called Seren that does run on Linux and the Raspberry Pi. That was Cherney, the cat, the house cat here, that just went by. So we have, we're separating the audio as an experiment to see how well it does for Morse code, and I'm also using a tower here, a tube tower that's resonant at about 700 Hertz. That increases the volume of the Morse code coming in about 3 to 6 dB. On the right side is just for voice audio. So we have on the left channel Morse code, and on the right channel we're going to have voice audio from a microphone or from a podcast. Right now I'm just going to demonstrate with podcast audio and not my own voice, but it would be the same idea. So on the Raspberry Pi, the demands are pretty low. Since we're only using the Pi's sound card, we don't need a monitor, don't need a mouse, don't need a keyboard, since we're using real VNC to connect to the Pi to see the desktop screen to set up this Seren program. Now Seren will run on PULSEAUDIO or ALSA, and I'm using ALSA right now just so I don't have to load up PULSEAUDIO. So I've chosen the Pi's own sound card as its output for Seren, and in Seren you can also determine what the input sound card is. Since the Pi does not have an input sound card, I've directed it towards an ALSA loopback cable. So I've listed the ALSA loopback, and I'll put the command structure in the show notes below. So I listed the ALSA loopback as the input sound card for Seren. And I've listed the Raspberry Pi's own sound card, the BCM 2835 here, as you see on the ALSA mixer at the top left. I've listed this one as Seren's audio output device. And so everything's running fine. We're running at 64 K as far as the bit, and 48K as far as the sample rate. We're running in stereo so that we can separate the left and right channels. The Seren on the left is the Raspberry Pi's own Seren, and it's set up with the name Raspberry_Pi. On the right is the laptop emulating a connection from outside the house here. Since I'm on the LAN, it does work over the WAN as well, as long as you forward port 8110 to the Raspberry Pi computer. That's pretty easy to do. So whether it's on the LAN or WAN, this will sound pretty much the same. Opus, and especially this Seren's Opus setup, does a really good job of recovering from lost packets, delayed packets. It has good packet loss concealment. So I've hardly noticed any audio glitches at all. So on the right upper side is the laptop's Seren client, and this is run in terminal because it's a command line program. So on the laptop I am using PULSEAUDIO, so it's just Seren-D Pulse, and that brings PULSEAUDIO into view. And then you can use the PULSEAUDIO volume control to select which of the PULSEAUDIO sound cards that you want Seren to use. So I'm going to send some audio now from the laptop to its Seren input on the laptop. Oh, and that will go to the Seren on the Pi, and then out that analog sound card, the speaker jack on the Pi. And I've got an audio tap of the audio going to these speakers, and you'll be able to hear exactly what that sounds like. So let me do this first and show you the README from Seren. And that will of course be in the file yourself, but if you wanted to take a look at it, there it is. You can freeze frame the video and take a look at that. So let's go back over here, And because I have a sound tap, I have a spectrum analyzer on the left channel and the right channel, a peak meter on both channels. My mic's going to both left and right, but Morse code's only going to be in the left, and voice audio is only going to be in the right channel. And we have a scope down here at the bottom so you can look at the waveform. Every second it's going to renew and freeze frame everything. So let's send some Morse code with FL Digi here. So that sounds pretty good. So Seren's doing a very nice job with Morse code audio tones. Now we're going to bring up a podcast from here. And that'll be in the show notes too. It's a pretty interesting podcast with Art Bell being interviewed.
And did very well in the ratings. But just for the hams out there, I thought I'd tell you, Eric, there were about 10 or 15 times that I actually went over to the console, put my finger on the switch that would turn us non-directional, because I wanted to see if I could get calls from other parts of the country.
So then voice sounds really good. So both Morse code audio and voice are doing really well. So again, the idea was to be able to take the Pi and just have it operate as a receiver. So you turn it on, you VNC into it, get Seren running, get the audio set up, and give it a test. And then you just have to send a friend of yours or a family member your IP address of the Raspberry Pi. They use that IP address when they're opening up their Seren. Their Seren connects to the Raspberry Pi Seren, and then they can send audio to you. Now, for you to send audio back to them, you could use the Raspberry Pi, but then you would have to get another sound card for some audio input. So the idea was that you set up two Raspberry Pis, one for each of you, and then you give the other person the IP address. So you have kind of two individual one-way audios, from them to you and from you to them, and sort of like an intercom. And this was just to minimize the complexity of having to bring in input audio to the Raspberry Pi. However, it's already set up for output audio, and this was just an experiment to see how well it would sound. Thank you for watching.